All right, so this is a very low quality video because I'm out of screen recordings. I've hit my limit. All right, so this is the lactase enzyme activity with data analysis. I've already clicked on this link to this. This is the experimental setup. So first, the pre-lab, you're going to define the following, explain how each relates to the lactase chemical reaction. So you are just going to you're just going to define these. You can Google these and you can tell me lactase is going to be the enzyme, and we're going to break down lactose. All right. So right here, the simulation option 1, we are going to be changing the temperatures. Okay, so if you'll see, we have 0, 20, 40, 60, and 80 degrees. It says start with the initial lactose at 500 milligrams per deciliter. And so we're going to look over here. We have 500 milligrams of the lactose. That means we're putting that much of the substrate into the experiment. The pH is going to be at 7. pH is 7 right here. These are the controls. Do not vary these parameters while testing for temperature. They are environmental controls, meaning that they're going to stay the same throughout the entire experiment. The temperature is in degrees Celsius. All right. Vary the temperature by 20 degrees Celsius. So run each experiment 5 times so then we can get the average. All right, so what we're going to do is we're going to run it 5 times at 0 degrees Celsius. So I'm going to change my temperature to 0 degrees, and then I'm going to run this lab. And as you can see, there was 0 reaction, no glucose concentration. There was nothing to measure. So I would go over here and I would put 0. Okay, then I'm going to reset it, put it back to 0, run her again. All right, still 0. Okay, let's see if it does let me run it again. 0, run it again, 0, run it again, 0, run it again, 0 the whole time. So we're going to 0, 0, 0, 0, average them together. That means we're going to add those up, divide by 5. It's going to be 0. You do not have to do standard deviation, so you'll just get rid of these 2. Okay. Now we're going to go over here. We're going to reset it. We're going to put it at 20 degrees. See, I changed it right here, and then I'm going to run it. All right. So at the end of my time, I got about, see if it'll tell me. See if there's any quick way to do it. Okay. So I got about let's say 450. So I'm going to put 450. Okay. I'm going to run it again. I got about the same. Run it again. Same. Run it again, same, run it again. All right, so we're all about at the same amount. So then we're gonna continue to fill that out. And so then you'll change it, you'll reset it, you'll change it to 40. Okay, then you're gonna run it. All right, for the calculating the rate of reaction, what you're gonna do is rate of reaction is going to be, let's look over here, per minute. So how much glucose was produced per minute. So you'll look at the very end. We're going to look at, there was about 500 divided by 20. So 500 divided by 20. 500 divided by 20. It's going to be 25. So that means that at 40 degrees, my rate of reaction is 25 milligrams of glucose created per minute, that on average. And that is it. So the rate of reaction, it's going to show you, it's right here. But that's the setup. That's how you run it. When you graph it, you're going to graph the means. So you're going to graph all these averages right here. You don't worry about when it talks about standard deviation. Optimal temperature is like which temperature did it work the best on, so how the most glucose was produced. All right, and then you're going to do the same thing for this one, except for everything's going to stay the same. You're just going to change the pH. You're going to manipulate the pH. And that's it. That's how it works.